In this video we will try to repair this board. It comes from a gate opener which has the model of Beninka. It has two problems. Here we have two resistors are burned and we have a mechanical damage of the capacitor. I tested the capacitor. It has a short circuit here. This is the filter. It passes only infrared, and I use this LED, infrared LED, as a receiver. The gate has a model of Beninka. It's an Italian brand. I installed this type of gate many times ago, and I have a photo of the board of we have here the two resistors which are burned. We have the rectifier diode here. Here we see the damage of the two resistors. Each one 220 ohm. I will clean the board and remove the capacitor to test if we have a short circuit or it goes. So I removed the two burned resistors and I made some tests. I found that they are connected to this small SMD transistor. So we have here the AC input. We have this rectifier diode, and we have this is the SMD transistor. It's a PNP transistor. So we have here. This is the base, and this is the collector, and this is the emitter. And we have here the two resistors in parallel, 200 resistors in parallel, they are connected here. So I will remove this capacitor and I will check if we have a short circuit or not. And I will, if it was okay, I will replace the two resistors and we will test this PCB. I will use some solder. It has a mechanical damage, so maybe it was internally short circuit. Maybe shorted internally. So we remove this capacitor. Now we will do the test. The short circuit is gone, so maybe this capacitor is the origin of the short circuit. We have it was okay, maybe. We will test again this board. We have now short circuit. And here it was okay. So I will replace the capacitor and put this to 220 ohm resistor. So if 100 ohm may work it fine. So it's 50 volt, 220 ohm. This one is 16 volt. It will not work it. We have 28 volt. This 16 volt. This one is 25 volt. .7 microfarad, 25 volt. This one is 16 volt, 10 volt, 3.3 microfarad. This is 50 volt, 10 microfarad, and the original it was 220, and this is 10. This one 35 microfarad. This is 35. So we have 28 volt multiplied by square root of 2. $40 volt. So at least it must has 40 volt. So this is why they choose 50 volt, the maximum voltage after rectification. I will pause the video in order to search in other places or maybe other card. I found this capacitor in this outlet ADSL box. It hasn't the same shape. I will test the board with this capacitor, and if it's okay, I will find a smaller one. We must add some fresh solder here to remove the capacitor. I will increase the temp. So in order to test this circuit, I will search for an infrared LED. We know this is maybe red one. I will use 100 ohm. I will test the LED first. It has 0.9 volt, so it may be okay. We need another wire. this is the first lead. I didn't know the frequency used here. I will try around 20 to 40 kilohertz. I will bring the generator and I will test. I managed to repair the circuit. It needs a connection between the plus VCC and the other component. So we have the testing setup here. We have the power supply, which delivers 26 volt to this board, the receiver, and we have the transmitter. The transmitter is made with one LED, infrared LED, and 100 ohm resistor in series. So this LED will be powered by this generator. We will set up the frequency at 25 kilohertz, the amplitude 4 volt. We will output the sinusoidal wave. So at 25 kilohertz, the board receives the signal, and when we cut the beam, the relay cut the connection. We have two connections here. Normally the relay is connected, and when we cut the beam, the circuit will be cut. We can see the waveform in the oscilloscope. This board functions with normally connected circuit, not normally open. The receiver is not tolerant for the frequency. We can test here. We can lower the frequency to 1 kilohertz. This is 1 kilohertz signal, and it still functions. Now we will find the upper limit. It still functions at 100 kilohertz. At 280, it shut off. Generally, it functions about 40 kilohertz or 25. The transmitter was okay. It functioned normally. It looks like this board. It has an oscillator and an infrared LED. This one works with 12 volt or 24 volt. So tomorrow I will test the receiver with the gate opener, and we will see the result. Now we have the gate in the closing phase. When I cut the beam, it reopens again. Thanks for watching, and for the next video.